Hello again viewers. So for our video tutorial here, we will talk about the Muller's method. So basically a Muller's method, the general idea here is that, say that we have our function here, we take three initial guesses, 3 points in our function. I'm just gonna draw a line here. This would be denoted as our x0. And for the next one would be our x1, and then for the next one would be our x2. So our x0, x1, and x2 are our initial guesses. And then we are going to find another point here near the x of 2, and this would be denoted as x of 3. Now in order to get x of 3, we must evaluate and solve a lot of use a lot of formulas to get this x of 3 here using our fundamental or initial guesses, x0, x1. So remember that. I'm just going to erase it here because we need space, and Muller's method has a lot of computations processes. So say that we have a function here given x of 3 minus 25x equals -9. Always remember that we are solving, the format should be f of x equals 0. So what we're going to do is just transpose this -9 to the other side. Our function would become x of 3 minus 25x plus 9 equals 0. And then we must take our initial guesses. So x0, x1, and x of 2. For x0, I would want 7, x1 would be 6, and this would be 1. Now, we are going to evaluate our function using our initial guesses here, 7, 6, and 1, so that the value for the function of x0, we're just going to substitute this 7 into our equation here. We have 7 cubed minus 25 times 7 plus 9. This would be 177 for our function of x1. That would be, our initial guess here is 6. Just substitute it here. 6 cubed minus 25 times 6 plus 9. That would be 75. And for x0, x0 would be 1 cubed minus 25 times 1 plus 9 is equals to -15. Next is, we're going to solve for the h0 and h1. So for h0, that would only be x1 minus x0. I just want to put a line here so that you don't get confused, or I don't get confused rather. So x of 1, that would be 6 minus 7. Our h sub 0 would be -1. For h1, that would be x2 minus x1, that is 1 minus 6, would be -5. So I just put a line here so that you could easily see the steps. Function were evaluated, then we get the h0, h1, and next is we get the sigma. Sigma sub 0, that would be the function of x of 1 minus the function of x of 0 over our h0. So for our x1 here, our value is 75. Let's put here 75 minus our x of 0 function is 177 over our h0 is -1. This would be 102. And then for our sigma sub 1, that would be the function of x2 minus the function of x1 divided by h1. That would be -15 here, value of our our x2 rather, to here, so that would be -15 minus 75 over our h1 got erased. So we did 5 here, this would be 18. Next step is that we find the value of A, B, and C for the formula of A. There's a lot of formulas really here, so you just have to memorize it all. So for A, that would be x1 sigma 1 minus sigma 0 over h1 plus h0, that would be 18 minus 1 over 2 divided by our negative 5 plus negative 1, and that would be 14. For our B, it would be A. Our value of A here is 14. So A times H1 plus sigma of 1, that would be 14 times negative 5 plus our sigma is 18, that would be negative 52. And for finding the C, this is the easiest one. So it's just the function of x of 2, which we already solved in the first step here. So our the function of x2 is negative 15. So first step, second step, third step, fourth step, and then the next step is to evaluate the x of 3. So for the formula of this, that would be x2 plus negative 2c. You have to remember this formula along with this one. You cannot solve Muller's method without memorizing it, so you just have to trust me and have to memorize it. It's just easy if you keep on practicing it. So it will be b plus minus square root of b squared minus 4ac, and then we're just going to substitute the value that we got from here. So x of 2 is 1 plus negative 2. Our c is negative 15. Over b is negative 52. Now for the sign here, this part, we will choose the sign according to the sign of the value of b, of our b. So since this is negative 52, we will put negative here, and then b squared negative 52 squared minus 4 times a is 14, and then c is negative 15. Our x of 3 would approximately be 0.7310. Yes, is 10. And next, in order to check if we are near the real value of our roots, we have to check for the approximation error, which is value of x of 3 minus x of 2 over x of 3 is absolute value multiplied by 100. So this would become 0.73, then minus our value of x of 2 is 1 here, divided by 0.7310. Don't forget the absolute value here, multiplied by 100. Our approximation error would become 36.7989%. That means that we still have to iterate it so that we would get to a nearer value or closer value for it. So here, our x of 3 is 0.7310. As I've told earlier, if we got the x of 3 here, since for the first, we have our initial guess, x0, x1, x2. Actually, this is not part of the computations. I'm just trying to let you know how it is implemented. So x0 is 7, and this is 6, and also this is 1. Now, since we got our x of 3 here as 0.7310, our x of 2, this would be our x of 2, and this is our x of 1. Our previous value of x of 2, that would be our x of 1 now. And then our x of 0 would be our previous value of x of 1, that would be 6. So that's it. Just iterate it and so that we get to another closer part. Thank you for watching.